Hello students. Hello and welcome to this video. In this video, we will solve question number 71 to 80. The link to download the PDF will be in description, as well as at the end I will show you from my website how you can download and maintain updated copy of the PDF. I will also show you question answer website which I have developed for you so that you can come ask questions or answer questions. So question 70, without further ado, let's get started. Question 71 says that for what value of k the following system of equations possess non-trivial solutions. Also find all the solutions of the system for the value of k. X plus the equations are x plus y minus kz is equal to 0, 3x minus y minus 2x is equal to 0, x minus y plus 2x, this should be z is equal to 0. Okay. So we have delta is equal to 1, 1 minus k, g minus 1 minus 2, 1 minus 1, 2. It should be 0 for non-trivial solutions. That is k is equal to 6. Once you have k is equal to 6, you solve the system of equations. You get z is equal to x plus x upon 2 and y is equal to 2x. So the solution is given by x is equal to t, y is equal to 2t, z is equal to t upon 2, where t is an arbitrary number. Now we have to solve some equations by Cramer rule. First is x minus 2y is equal to 0. Second is 7x plus 6y is equal to 40. So our delta is 1 minus 2 and 7, 6. That is 6 plus 14, 20. And delta 1 would be 80. Delta 2 would be 1, 0, 7, 40. That is 40. X is equal to delta 1 upon delta. That is 4. And y is equal to delta 2 upon delta. That is 2. 73 is x plus y plus z is equal to 9, 3x plus 2y minus 3z is equal to 0, z minus x is equal to 2. So our delta is 111, that is quotient of 3 is here. Then we have 3, 2 minus 3, that is quotient of 3. And finally we have minus 101, that is the quotient of the last equation. And upon expansion it gives 4. Then we have delta 1, we substitute the constants for quotient of x. So the first column becomes 902 and we evaluate it is 8. Then we have quotients of y being replaced by the constant, delta 2 is 12. And similarly, delta 3 is 16. Once we have that, x is equal to delta 1 upon delta 2, y is equal to delta 2 upon delta 3, z is equal to delta 3 upon delta, that is 4. Question 74, we will solve similarly. The equations are x minus y plus z is equal to 0, 2x plus 3y minus 5z is equal to 7, 3x minus 4y plus 2z is equal to minus 1. So first we have delta made up of quotients of x, y, and z, and we evaluate it to be 12. Then we replace quotient of x by constants, and we have delta 1 is equal to 16. Similarly, by replacing quotients of y in the second column, delta 2 is equal to minus 14. And delta 3 by replacing the coefficients of z by constants, that is what is on the right hand side. We have delta 3 is equal to 2 and 3. So once we have that, x is equal to 4 upon 3, y is equal to minus 7 upon 6, z is equal to 1 upon 6. Question 76 says that we have to solve these equations. X plus y plus z is equal to 1, x plus by plus cz is equal to k, a square x plus b square y plus c square z is equal to k square, where a is not equal to b is not equal to c. We had to do 75, I read 76. So we have to solve question 75, 2x plus 3y minus 3z is equal to 0, 5x minus 2y plus 2z is equal to 19, x plus 7y minus 5z is equal to 5. So we compute the determinant of coefficients of x, y, z. We get 38 as the answer of one expansion. Now we replace coefficient of x by the constants on right hand side, that is 0, 19, and 5. So first column is replaced, and delta 1 is now minus 114. Similarly, we replace coefficients of y by the constant, delta 2 becomes minus 228, and delta 3 for after replacing coefficients of z by 0, 19, and 5 is minus 304. Once we have all those, x is equal to delta 1 upon delta, that is 3, y is equal to delta 2 upon delta map is equal to 6 and z is equal to 8. Now, similarly, I already read the question 76. We have the determinant delta is equal to 1, 1, 1, ABC, A square, B square, C square, which we have evaluated earlier to be equal to A minus B times B minus C times C minus A. Now, upon replacing the coefficient of x with constants, we have 1 k square. So, delta 1 is equal to k minus b, b minus c, c minus k. And similarly, for coefficients of y, upon replacement, they become 1 k square. So, delta 2 is k minus k, k minus c, c minus a. And similarly, we compute delta 3. And once we have that, we have x is equal to k minus b times k minus c over a minus b times a minus c, which is delta 1 upon delta. Y will be delta 2 upon delta, that is k minus a times k minus c over b minus a times b minus c. And z would be k minus a times k minus b over c minus a times c minus b. Now, we have to determine whether the following system of equations have no solution, unique solution, or there's an infinite number of solutions. So first system of equation is cx plus 9y is equal to 5, 9x plus 27y is equal to 10. So here delta is equal to 0, delta 1 is equal to 0. Sorry, not equal to 0. As the given system of equations is inconsistent and has no solution. Now, if you don't remember all that, okay, so what you should do is should come and look at this. Where did that go? I missed it. System of linear equations. Table 2. Yeah. So this section you should refer to. Okay. So when delta is 0 and delta 1 is not equal to 0, the system of equations become inconsistent. Delta 1, delta 2, delta 3, any of them is non-zero. The solution of equations become inconsistent because delta 1 upon delta will become infinity. And when delta 1, delta 2, delta 3 all are zero, so system becomes system has infinite number of solution, and when delta is not equal to 0 and this solutions on delta 1, delta 2, delta 3 also could not be equal to 0. The system of equations will have unique solution. Even though in this case, if you see delta 1, delta 2, delta 3 are 0, the solution will be infinity, right? So still you will have a unique solution. Okay. So we go back to question number 77, I believe. Yeah. Okay. So now we have this. So we compute this and we have delta is equal to 0. Delta 1 is not equal to 0. So given system of equations is inconsistent and has no solution. Question 78 is 5x minus 2y is equal to 3x plus y is equal to 7. So delta is not equal to 0, delta 1 is equal to not equal to 0, delta 2 is not equal to 0. So given system of equations have unique solution. Question 79 is x plus 2y is equal to 5, 3x plus 6y is equal to 15. So here delta is equal to 0, delta 1 is equal to 0, delta 2 is equal to 0. So the given system of equations has infinite solutions. Question 80 is 2x plus 3y plus z is equal to 5, 3x plus y plus 5z is equal to 7, x plus 4y minus 3z is equal to 3. So here delta is 0 and delta 1 is equal to 2. So the given system of equations become inconsistent and has no solution. So with this, we come to the end of question number 80. And now I'll show you my website. So ashtavakra.org is the website. Let me zoom it a bit. So question 2, links 2, 3, and 4 are PDF links of algebra, trigonometry, and geometry books. Now, the date mentioned here will not be in the PDF, so you need to add this date when you download it. Okay, for example, coordinate geometry was updated today. I cannot add the date to the PDF itself because that will make all existing links invalid. Now, Coordinate Geometry book is also available in HTML format, which you can read. I will recommend Firefox browser. So, why Firefox is recommended is because it contains MathML. So, right now I'm working on the miscellaneous problems. So, we have, let's see how many problems we have. We have 82 problems on miscellaneous problems. So, this math you see is MathML, and Firefox is the best engine for MathML learning. As far as I know, latest version of Safari, Chrome, and Edge will also work. Older browsers like Internet Explorer and older versions of Chrome and Safari will not work. You need quite recent versions of that. Okay. Also, the question answer website where you can come and ask questions is this pundika.developer.org. You can come here and ask questions or answer questions. You can make use of the tabs algebra, calculus, coordinate geometry, mathematics, probability, and trigonometry. If I'm not able to answer your question, there is a chance that somebody else will answer your question. Okay, so let's build a community and let's learn from each other and grow together. So please make a login and ask questions here because, for example, on YouTube you can't start determinants, right? But here we can. On Pundika you can create determinants. What I will do is I will make a cheat sheet of math type. Okay. So with this, I will end this video here, and we'll meet again tomorrow with 10 more problems on determinants. Till then, stay curious, keep learning, and most importantly, enjoy.